I can see that still drop in participants, but since we are over 60 registered participants, I want you to follow the recommendations that the yellow symbols show in the picture. Be muted, raise the hand. It has been an exciting year with the startup of projects in which we participate and which I definitely believe will have a very positive impact, such as Arrowhead FPVN and industrial data ontology, for example. But there are several ongoing activities that all points in the same direction. Slide 2, please. At this year's summit, we will try to highlight how can we convincing the management of our Swedish industrial companies that digitization is not just a buzzword. We know that it is a comprehensive cultural change that requires the management's commitment, of course, and also control. And yeah, of course, if you ask yourself, why should we or digitize? The question is not if, the question is when. And because we know that companies that succeed gain competitive advantages. Next slide, please. Here we have a slide with our members and partners at the moment. I will say I'm happy about the spread because we have members from plant owners, software companies, consultants, manufacturers, universities, and we also have partners. We have the organizations also that work with standardization. Next slide, please. So the agenda for today, we have Robert Skaar from Equinor, and he will talk about ILAP. We have Peter Townson, and he have a presentation about how company management can use CFIHOS, for example. After that, we have Henrik Wikberg, and he will talk about the urgency of digitization, the obstacles of going digital in manufacturing and how we can overcome them. And then we also have Monica Hole from Aibel. She will talk about the journey of digitalization of process flow diagrams and development of DEXPI process, and how we can go to intelligent P&IDs. And at the end, also some project status. You are very welcome, I will say. And now over to our moderator, Mats Larsson, and also Erik Molin.
Yes, hello.
Hello. Welcome everybody to this year's version of SEIIA Summit. Special welcome to our first guest, but first I can introduce myself. My name is Mats Larsson, and I'm together with Erik. We'll take care of you today during this afternoon, and I hope that will be really interesting because we have really interesting things to listen to this afternoon. So once again, welcome.
Hello, my name is Erik Molin, and I'm operations in SEIIA, and I will start to this SEIIA summit with something, and then we will leave left over to Robert.
Yeah. So with that, I will say hello and welcome to Robert.
Hello.
Yeah. Hello. First, we start with a short presentation of Erik.
Yes, I will start with something about SEIIA. Maybe not all in the audience are well known about what we are doing. As maybe some of you know that we are a non-profit association that works with standardization for interoperability issues in the handover process in the industry. And we also participate in several international standardization efforts during this to increase this one in global and also but in Sweden. And some fundamental things in our community and in our society is that we don't want to reinvent any wheels. And we also think that this is a very we need to focus on that. This is a global question, not a local Swedish or company question. We need to work with this type of initiatives in a global way. And the next one is that we are open, not closed, to non-proprietary systems, and strategy is not what we want to work with. So I will start with a film about reference data. What's our reference data that we have found out is not directly connected to what we are talking today, but I think it's a good example of what we are trying to achieve with our organizations. Now it will come on film. I stop there, and just before we let Robert go into the scene, I would just focus on what we are doing in our community and in SEIIA. We are trying to improve the use of reference data, and as you see in the film, the passport you are using when you're traveling, that's also based on reference data. And our mission is that industry in Sweden should use international reference data for their ERP systems, engineering systems, and systems overall in the IT, what you say, IT systems you have in your plants. So, and one of them are ISO 59006. That is one of the standards that we are promoting, and connected to them we have also CFIHOS and DEXPI, but we come back to that later. So that was a little bit introduction about what we are trying to convince the Swedish industry about, and we hope that the rest of the presentations today convince you more and get you more ideas, and I will come back in the end and talk a little bit what we are doing also in Sweden. So let us hear what Robert have to tell us. Welcome, Robert.
Thank you very much, Eric. I don't have a share button in this Teams, so I sent the presentation to you, Eric. Could you share my presentation? Thank you very much. Hi, everyone. Thank you for the invitation to present what we call ILAP. It's an abbreviation for Integrated Lifecycle Asset Planning. For us, it's all about being more effective in terms of time and cost to have better control. Next. Yeah, I have added some more slides. I will start with an introduction to the topic. Next. A question we can ask is, do we trust our data? I'm quite sure that everyone trusts our bank account data, although it might be less money than we expect. When we check it, we trust it. But do you have the same confidence and or trust in your schedules? Next. Don't know if you're familiar with it, but all payments are going through a service called SWIFT, which is the international industry service for exchange of payments or money, and they are based on ISO 20022. So we have an international standards for enabling interoperability of money. As one example. Next. We do not have the same type of service for schedule data internationally. We have started and we are developing it, but we don't have the same international service as we do have for money and payment. Next. So, schedule data. Why is it important and why should we care? Next. I'm a planner of training. I give lectures in scheduling. I study planning and scheduling, and I am very confident that Egyptians had schedules when they built the pyramids. Of course, not using computers, and they were simple, but there is no possibility to build the pyramids without schedules of some sort. So schedule data have been with mankind since, or at least several tens of thousands of years is my belief. But next. Today, schedule data is used by everyone, every industry, both public and private. We use it for projects, supply chain, logistics, assembling, operation maintenance, but also if you want to do proper risk management, you need to have schedules because schedules are the only thing that is telling us who is doing what, when and where in the future. Next. So then, as Eric introduced to us too, we do not want to reinvent the wheel and to achieve interoperability, we need an ISO standard, a standard where we agree across countries and industries on the terms and definitions for the scheduled data. Next. And digitalization have been a topic actually for more than 50 years. It started back at least in 1969, when they barcode scanned a Wrigley chewing gum. So it's not something new. But today we need to be, as before, even more effective, and to achieve that, we need to both share and exchange schedule data across the supply chain and the value chain. Because schedule data is the only data telling us who is doing what, when, and where. And we have delivery dates and need dates in the schedule. But the challenge is that every scheduling tool uses their proprietary terms and definitions. A special feature with scheduling tools is that they have what's called user-defined fields, and there are more than 200 free fields, which can be defined by each planner. And thirdly, they also do their own calculation. To achieve interoperability, we therefore need an ISO standard that we agree across countries and industries. Next. So here are some concrete examples of some differences among some scheduling tools. If we should make a list of everything, it will be a separate presentation by itself. But the time 000 and or 2400 is in scheduling very different, because 000 means start of the day and 2400 means the end of the day. And if you mix those, which they do, you need to subtract or add a day exchanging schedule data. Also, some scheduling tools use the term progress, how much have you done? Other ones only use remaining hours. And there are different progress numbers and different remaining hour numbers. So we need to agree, how do we exchange this? A schedule have calendars, meaning working time, and there the setup and use is different. Also, critical path, for those of you that know scheduling, is the shortest possible time to achieve a task. That is done differently. And also, when we want to see how much people we need in the coming days, weeks, months, years, we need to prioritize activities. That is also done differently. So when you look at the schedule, it's only valid for that scheduling tool. If you exchange, it will not be valid. Next. Why should you care about schedule data? First and foremost, to protect life. As I said, schedule data is imperative to do proper risk management, because it's only information that tells who is going to do what, when, and where. Also, when there are different companies and people on a site or in a factory or wherever, to coordinate them, we need to see what they plan to do. That is in the schedule. So if you want proper, effective coordination, you need to use schedule data. Schedules are also the best to analyze performance in a project, and also to predict the outcome of the task which we execute. Next. So we started back in 2012 with the schedule data initiative, and I will say what we have done and where we're heading. Next. Yeah, I said earlier that schedule data is not standardized. That is partly true. We made the ISO 15926 Part 13 in 2014 to 15. We spent 18 months, which is extremely quick for an ISO standard. We have also established an industry service, but so far it's limited. But after Q3, Q4 next year, we are ready to expand. Next. So the first exchange of scheduled data was October 2018. This is in oil and gas and in capital projects. Since then, we have also tried it in electric infrastructure project construction and also for helicopter coordination. We also plan to use a use case for both vessels and trucks. This is mostly the long-term need for helicopter vessels and trucks. It's currently been used by 4 different owner-operators and 8 different contractors in more than 50 projects. We have exchanged some 1,000 schedules, I haven't counted it, and more than 1 million activities. And currently, we also have a waiting list for new users that wants to use ILAP. Next. Yeah. So looking forward, we want to have an integrated supply chain exchange of schedule data, where vendor suppliers exchange with contractors and with owner-operators, and also internally within owner-operators, so that we get an integrated supply and value chain data flow, updated instantly, because today it can take up to 8 weeks to get schedules updated in large projects. That should happen within 24 hours. It could and should be used for assembly lines for the integrated supply chain, capital projects, of course, maintenance, and also integrated schedules is what we call the schedules we do for risk management, where we coordinate actors and make sure it's not too risky. So, next. What are we doing now? Next. So, September last year, we started to update the software because today it's a desktop solution, and now we are building a native cloud solution, which is by design global scalable to every country that have a, for now, Microsoft data center, can be expanded to Google, Amazon later if wanted or needed. And this is important because it's not easy to send data across borders. Some countries have strict regulations of that. Next. So now we're also moving from today's situation where every planner exchange their schedule data to a corporate monitoring and exchange of schedule data. So a company which maybe have 300 planners can reduce the number of people involved to 3. With this solution, it takes between 3 and 5 minutes to set up a new schedule exchange if you're familiar with it. And this is the morning picture, I say. When I start my job, I enter this monitor and see how many have failed, are there delays, overdue, are there some paused, and how many do we have in total. I can search and troubleshoot from this. We expect more than 10,000 schedules exchanges by the end of next year. within Equinor, at least. Next. And also in this native updated cloud solution, we have the ISO standard, and we use also existing ISO standard. ISO 3166 is an old standard. Many users across the world, industries and companies, but not everyone. But there's defined the term country, and then we need to agree how do we write the name of the country. This can be configured in the industry service, and for country it will. Then we know that everyone that exchange country in a schedule have trustworthy use of both the term country and the content Sweden. Next. This is also enabling new feature which I think is impossible today. We could make a corporate dashboard for schedule data across all industries a corporation are involved in and across all countries, but it will take a lot of man hours, and the cost will be higher than the benefit. With ILAP data exchange, this is kind of done more or less automatically because we have standardized schedule data. It's just to set up a dashboard across all industries and countries a corporation is involved in. Next. Also, having all schedule data in a corporate database across all industries and countries, you can develop KPIs. And this is an example. This is only demo data because we're not allowed to share actual data. But this shows a list of all current projects ongoing with KPI of does it change too much? Are they performing okay? Is the quality of the schedule okay? And do they deliver on time? Here we can click on a KPI, which is red, and see on the right side, these activities are the ones causing this KPI to be red across all industries and all countries a corporation are having projects under operation. Next. We can also do then corporate performance monitoring. How are we doing across all industries and countries we're involved in? And I don't have time to show this live, but here I can in one click see how one contractor performs across all countries and industry we use them. I can check discipline project phase within 1 and/or 2 click at corporate level. Next. And I can also see future need for manning across all industries and countries a corporation are having activities and operations. And click on phase discipline project if I want to and need to. Next. Thank you for your time and attention. Over to you, Eric.
Yes, thank you, Robert. I don't have any questions from the audience. Do you have anyone? So please raise your hand. The question that I think of is if somebody is interested in this who listen to you now, what can they do if they want to learn more or interact with you?
Maybe contact you and you contact me.
Sounds wise.
Or I've also closed my email and phone number. But we are currently putting this in operation and scaling it with the current customers. So after next summer, we are ready to scale and move forward. But I can give presentation and discuss them if wanted.
Yes, we have a question from someone here. I cannot
Yep.
see who it is, but
Valentina.
Valentina, welcome.
Hello, everyone. Thank you, Robert. Very interesting presentation. So very interesting to hear about the standard for scheduling data. I just want to make sure I understand correctly. So you have a tool where there is scheduling information entered by different companies and different industries in a standard way. Is that correct?
Yep.
Yeah. Is it also possible that the other scheduling tools implement that standard and that they can exchange that information between each other? Okay, yeah.
It's
So
just
it's
to
not
make kind of API for that scheduling tool, and then we're up and running. We're currently supporting SAP, Primavera P6, Microsoft Project, the old name, Safran, and Excel. And that covers more than 80% of all scheduling tools in the world. But overall, we hope it will be implemented in more than 200 scheduling tools over time.
but that's great. Yeah. Thank you so much. Very interesting. Yeah.
Thank you.
Yeah, really interesting, and I think also you have achieved something quite big or with a big impact in a relative short time to me.
Yeah, I'm impatient by nature, so I think I've been working with this now for 11 years, and I should have wished it happened faster, but it takes time, and if it takes time, it's more solid. We presented this project at the International ISO meeting in USA last week, and we also got a very good response on that meeting.
Good. Interesting. Any more questions from the audience? No. In that case, I will make a big thank you to you, Robert, for that, and hope that you join the rest of this afternoon with us. And also welcome the next guest, Peter. Are you with us, Peter?
Yes, I'm here. Yeah, I'll just share my my presentation.
Yes, very welcome to you, Peter. And I think you can introduce yourself to start with, and then the stage is yours.
Okay, all right. So hopefully everybody can see my my screen. If not, just say so. Yeah,
we don't see the presentation view, I think.
How about that?
Now we see the right one.
Okay. Yeah, just by way of introduction, I am the project director of CFIHOS. I've actually been involved with CFIHOS for many years. It goes back to about 2014 in a former life where I used to work for Woodside. But since 2019, I've been the project director for CFIHOS when the governorship changed from USPI in the Netherlands to IOGP. So that's a little bit about me. What I'm going to talk about today, hopefully if it will change, there we go, is just give people a little bit of an overview of CFIHOS, because I'm making the assumption that not everybody is aware or necessarily understands all the details of CFIHOS. A little bit about implementation and quality. Mention our face-to-face, and that's important because that's refocused our roadmap, and then go and talk a little bit about CFIHOS and what management needs from CFIHOS and how CFIHOS can help meet some of those needs of management, particularly senior management. And then hopefully there'll be some time for some questions as well. So just a little bit about CFIHOS. It stands for Capital Facility Information Handover Specification, and then when we tend to pronounce it CFIHOS, there's lots of people. Some people will say CFIHOS and other pronunciations, but the term we use is CFIHOS. And our main purpose is to create a handover specification. And it's very important that this handover specification is practical and can be implemented right across the supply chain. So when we talk about the supply chain, we talk about, owner operators, the contractors that deliver that, be they EPC contractors or be they construction contractors or fabricators, equipment manufacturers and suppliers of equipment and materials. So it's a standardized way of exchanging and a standardized set of information against a class or a type of equipment or a type of plant right across the whole supply chain. And that doesn't mean that it's a single event that happens at the end of a project. It is actually happens multiple handovers right through the project, from concept to select, into feed, into execute, and then into operations, and then ultimately to decommissioning or disposal of the asset that's compliant to CFIHOS. And it's important to bear in mind as well that the information that we're talking about here is to own and operate and maintain a facility and do that safely and efficiently, and really importantly, be able to demonstrate compliance to the regulator. Now, whether that's an oil and gas regulator or an offshore wind regulator or a chemical regulator, all asset-intensive industries usually have a regulator of some sort, and it's very important that you have the information to actually, maintain your license to operate. And obviously, the reason we're doing this is to actually significantly lower the total life cycle cost of owning an asset. Historically, some organizations, say in operations, that their engineering departments spend anything from 15 to 20% of their time looking for and validating information. So if we can get the concise set of information delivered to the operation so that they can operate the facility, that will significantly lower the life cycle cost of the facility. So a little bit about the key elements of CFIHOS. There's really three key components to CFIHOS. We start with what we call our narrative documents library, and that's made up of what we call our scope and procedures document. We have a technical specification document as well. That's the rules and the principles around information handover. And very importantly, we have process and guidance documents. And I'll talk a little bit later about the process and guidance documents, but they are very important documents to help people go around or go about implementation of CFIHOS. Then it's what most people consider to be the heart of CFIHOS is we've got the data model and the reference data library that goes along with that data model. The data model itself is what we call a logical model, and those that are familiar with data modeling will understand what I mean by that. It's not a physical data model that you would necessarily build a database to. It is actually sort of the IKEA instructions as how to assemble CFIHOS, because CFIHOS does need some assembly in terms of the reference data when it's delivered. It's delivered in a very flat format, but it's actually much more than just a flat set of data. It is three-dimensional or even a cube, and you need the data model to help you assemble the reference data. Equally, for our members, if they do want a set of SQL scripts to build a physical model, we can export it from the tools that we use to maintain our data model. So that's the sort of like the key deliverables. And it's important to say that CFIHOS is free. It does come with a license, but it's an open source license, and all you have to do is recognize the source. If you go to the CFIHOS website, all of these elements that I've just talked about here are available to download and to be used by any organization in any industry. There's no restriction on the use of CFIHOS. Right, just a little bit about our membership. Our membership is quite significant now. It has grown over the last few years, but this year we've seen a significant increase in organizations joining us. So if you look at those membership groups there, we've got what we call the IOGP owner operator groups. We've got non-IOGP owner operators as well, and they represent things like the nuclear industry, the chemical industry, and LNG and water industries with NEOM. We've got what we call our equipment suppliers and other institutions. So we've got a couple of universities on board, and we've also got some equipment suppliers. We are very weak in the equipment suppliers area, and we are looking to get more equipment suppliers involved, because as we said in our purpose, it is very important that the CFIHOS can be used right across the supply chain. We have quite a number of EPC contractors, 21 of them, and as you can see, they represent some of the world's major EPC contractors, and I think all of the major EPC contractors are part of CFIHOS. Then we've got the software vendors and consultants, and that's by far our biggest group. We've got 32 of those on board. But the ones highlighted in yellow are the people that have joined us since September last year. So we've had 15 new organizations joining us, and that has taken the total to 81 organizations that are actually actively participating in CFIHOS. And there is well over 400 SMEs from those various organizations helping to develop the content. So over the years, there's been many millions of man hours put into the development of CFIHOS, and it has got to a stage now with the release of version 1.5, which was released in November 2021, that it is actually seeing widespread adoption now. Most of the people that have joined us is because they either are adopting CFIHOS and implementing it within a contract or specifying it in a contract, or they have received a contract or a set of software requirements for development that is actually has CFIHOS as part of it, those sets of requirements. Also, what we're doing is we're trying to make sure that we're aligned with what's happening in other development and other organizations doing similar sort of work to CFIHOS. We, like SEIIA, have a concept of we do not want to reinvent anything or invent anything, or equally have overlaps with any organization. So what we try to do is to work and collaborate with other organizations such as SEIIA, such as DEXPI, such as Nomura, and the FL3DMS work that's going on under USPI, where we have extensions to the CFIHOS data model, and where it's appropriate, we also have they use our reference data rather than actually duplicating the reference data. And that's very typical of the work that we're doing with CII and advanced work packaging. But we are doing it with others as well. So there's quite a number of organizations there. We are working very closely as well with ISO, and also ISO 14224, which is the reliability and maintenance data, and embedding part of that in CFIHOS, but again, not overlapping with that standard, and making sure that we get alignment. And we're doing the similar thing for cost and planning data with ISO 19008. So yeah, we're trying to make sure that we get alignment, and we're all working together, maybe at slightly different speeds, because we all can't achieve the same speed necessary in delivery, but certainly making sure that we get alignment as much as we possibly can. I won't go through the timeline too much here, just to say that the current version of CFIHOS is version 1.5.1, But having said that, version 1.5 is the one that is being predominantly implemented. Version 1.5.1 was only issued this year, but as you can see, we've got quite a timeline and quite a history. CFIHOS has been around now for over 10 years, 11 years now. But as you can see from this sort of timeline, the cadence at which we're now starting to produce and deliver has gone up significantly since around 2020. So looking forward, in 2023, what we've done is we've published version 1.5. We've also published our first bilingual version, and that's in Chinese, and we're actually looking to produce more bilingual versions of CFIHOS. We have published now our adoption staircase or implementation staircase, and I'll talk a little bit about that later. And we're at the moment we're reworking our narrative documents to be more of requirements based as opposed to the traditional narrative where we include multiple requirements in a sentence or within a paragraph. And we're developing the content for our next release as well. Our next release is planned for Q2 next year, and it is going to be a major release. It's going to be called version 2, and the predominant reason for that is there's a lot of additional content to cover other industries, and also the reworking of the narrative documents has made a significant change, significant enough that we should actually call it version 2. And looking forward a little bit, as I say, we're going to publish version 2 hopefully in Q2 next year. We're developing a backlog now of work based on revised or refreshed roadmap and strategic goals. I've got a slide on that. And as we go through that, we will be publishing interim versions as and when we've got meaningful content. We're going to try and target an annual release, whether that's a full release or just a point release. Okay, in September this year, we also held our face-to-face meeting. We try to hold these once a year. There was over 100 attendees representing 47 companies from around the globe. It was actually hosted by Eastman Chemicals in Kingsport, Tennessee. Now, whilst the face-to-face itself was actually very important for us. Whilst we had all the usual presentations and things like that, we also had workshops, and we also tried to, or we did reinvigorate and refresh our roadmap. So that's the most significant deliverable that's actually come out of that face-to-face, is the refreshed roadmap that we've got, or strategic themes. So people that maybe are familiar with CFIHOS might have seen a very similar graphic to this, but the graphic had 12 strategic themes. We have actually reduced those themes, but sort of sharpened the focus of what we're trying to deliver. So we've got, and we've actually added an additional theme as well, which is the data maturity theme. And what that is establishing at various project phases, how mature should the data be? So we've got quite a comprehensive reference data library supported by the data model, but what it doesn't do at the moment, and what we're focusing on is within that data maturity element, is around at this particular project phase, say end of feed, how mature should the data be? What data should be filled in? What documents should you have? What the status, what the quality of the content of those documents and that data should be at those particular project milestones. So the thoughts are, end of feed, going into execute, issued for, or when you've got your design at a certain stage, whether it's following the model review process or another process, we don't know yet. But it's those key themes or key project milestones that we want to actually have a definition of the maturity of the data and the documentation to support that. Equally, we're focusing on spare parts, so the next version will have the data model so that the collection of spare parts and components can be included within CFIHOS. And we're working as well around the handing over of models. And when we talk about models, what we're talking about there is 2D and 2D models, you know, your P&ID data, working closely with DEXPI, and your 3D models, but equally there are other models. There's your instrumentation model, your electrical model, there's also your process models, those types of things as well. So they're sort of like some key areas of focus for us going forward. Also, just about implementation, as I said, we have produced or published our implementation staircase. It's got 5 steps to it. I won't necessarily go through every single step, but what we've tried to do is we've tried to break it down into what we call the specification itself, people and processes, and the technology that is required to support that. CFIHOS is technology and software agnostic, but equally companies that are implementing CFIHOS will have their own technologies and software, you know, their own ERP systems, their own project management systems that they use, and their engineering design tools, but they still need to be configured to support CFIHOS. So as we go through, you know, we've got the pre-adoption stages that people need to do some pre-adoption work, then define what that means within their organization. You know, like implementing any standard within an organization, there has to be some change management. There also has to be some definition and some training and some understanding. Then going on to embedding that within their organization, and then the use stage is where it's actually started to be specified in contracts and is actually being used. And then the final step, as we see it, and very few people are in the final step, I have to say, which is the assurance process to make sure that you've got what you expected. Is there anything that you need to refine in terms of your processes? Is there anything that CFIHOS needs to refine? So feedback to CFIHOS, any gaps or omissions that we've got. So that's part of the adoption staircase. The companies that you can see on the left of this slide are all companies that are currently implementing CFIHOS, and most of them are in the use phase. There's a couple that are in the assure phase. So if we take, who should we take? Should we take Petronas? They're going through that assure phase because they've used it now on 2 projects, and they're actually specifying CFIHOS on all of their future projects. So they're using it company-wide now. And the interesting feedback that we're getting from our members is that version 1.5 meets about 80% of their needs out of the box. Now, we CFIHOS feel that is a very, very good number, because it's never intended that CFIHOS will cover 100% of everybody's needs, because there's lots of different operating environments, there's lots of different operating jurisdictions, there's lots of edge cases that we don't think that we should cover. So we have this concept of the envelope we call it the envelope concept, which allows organizations to extend CFIHOS in a standardized way. Ultimately, some of that may get fed back into CFIHOS, but to extend it in a standardized way so that you get a standard approach to the extensions of it to cover those edge cases. Having said that, though, we are in the process of analyzing or getting feedback from companies to analyze what that 20% gap that they're all seeing, or more or less seeing, and if that is if there is a level of commonality amongst that 80%, then we will actually include it in the core of CFIHOS. But as I say, we don't ever expect it to cover 100% of everybody's needs. We also this year had our second measurement of implementation. And these are just the very high level takeaways. I can include, I'll make sure that Eric has this pack. I can include a bit more of the statistics in the pack that I send out. But basically what we're seeing is that over 90% of the organizations that are members of CFIHOS are implementing either parts or all of CFIHOS in full, and that includes all the documentation as well. 60% have already implemented or have mapped the CFIHOS reference data library to their own reference data library. And in some instances, they are just using the CFIHOS data reference data library with slight extensions. The document side of things is slightly lower. It's only about 50% of mapped the RDL for documents. And then again, 45% of them are actively involved in projects at the moment. They're either specified in a project, or they're the EPCs or the software suppliers are actually developing or executing projects that have CFIHOS as a requirement. That's quite a high number, we feel. So we've seen this sort of big uptick in the adoption since and the implementation since the release of version 1.5. There is a slight negative in there, is that the take-up of the specification and guidance documents is not as high as the other elements. It's relatively low. It's below 40% of people actually implementing them. I think it's about 37 or 36% off the top of my head, which is a concern for us. One is we want to make sure that those guidance documents and specification documents are useful, because there's a lot of effort gone into them. But having said that, a lot of the questions that I get asked personally when people are inquiring about CFIHOS or asking about implementation issues that they're having, some of those, or a high percentage of the answers, can be found in the guidance documents and the specification documents. But we are looking at that to see how we can improve that take up. Equally, we are getting from so this measurement is only people that are members of CFIHOS. So it's only from the 81 companies that are involved in CFIHOS. But our EPC and software vendors members are reporting to us that they are receiving numerous contracts and requirements from owner-operators that are not members of CFIHOS. So it is actually being taken up by and implemented by non-members, because it is free to use and free to download, as I said before. But we're seeing a high intake or uptake of non-members actually implementing CFIHOS as well. So that's around the implementation. And then also what we try to do is we try to measure the quality of our documentation and our deliverables. So these are all the main elements of CFIHOS that you can see across here. And we asked people to rank it from a score of 5, 5 being absolute perfection, and 0 being of very poor quality. And as you can see, most of them are scoring around about the 4 mark. So not perfect, but still we feel that these are very, very good measures of quality. Certainly good enough for people to implement. Okay, that's quite a lot about CFIHOS and the background and where we are. So a little bit about talking about management needs. So what we have at the core is we've developed over 20 personas for various users of CFIHOS. So we have sort of like a persona for an IM person, a persona for an engineer, or for a project engineer, or for an electrical engineer. We have a persona, say, for a software supplier and for an EPC contractor. So we've developed all these personas around their needs and their pains and their gains. So this is around the management. So here we've got what we call Eddie the exec, a persona for Eddie, and you see there, a little bit tongue in cheek, most likely to say, what can someone install a digital transformation on my laptop? That was a little bit tongue in cheek, but the management side of things is very important. So when I first talked to Eric about this presentation and about the management needs, I thought, oh, that'll be fairly straightforward. That should be quite interesting to do. But then I realized I ended up with lots and lots of slides about needs and how CFIHOS could address them. So what I've tried to do, taking this persona, I've tried to distill them down into what the management needs. And I've only got one slide on this, so hopefully we've got lots of questions. But actually, if you think about the management needs, or the needs of management in the sort of like the two key phases of a project, the execute phase and the operate phase, their wants and needs are actually quite small. They're very complicated, but they're actually quite small. So in the execute phase, if you was to talk to a project director or a project manager, what would his top few things be that he wants? What are his needs? And actually, the top priority for him is certainty in project delivery. And that includes doing it safely, to a schedule, to cost, and then ultimately handing over the entire project, not just the information to support that project, but the whole project to operations. And if you look at CFIHOS, how CFIHOS can impact that, CFIHOS is not a panacea that will solve all of project issues and project problems. It's dealing with if you talk about our purpose at the beginning, it's dealing with the information and data that's required to own and operate. So how can CFIHOS impact the execute phase for a project manager or for a project director? So having a clear definition of information that's required, and very importantly, understood by the whole supply chain, certainly aids certainty in the schedule and also the cost. Because if you're dealing with a standardized set of information for a standard piece of equipment, or standard class of equipment with a standard set of properties and a standard set of documentation that the supply chain understands, there's an awful lot of waste then removed from the system, a lot of recycle, a lot of man hours that are saved, and actually you get more certainty on your schedule, and you certainly can reduce your costs or become more efficient during that project phase. And actually handing over to operations. I've personally been involved in handovers where they've been absolute disasters and they've cost an absolute fortune, and they have actually delayed RFSU, ready for startup, or actually the startup of a facility, because certain critical information that you need to demonstrate compliance to the regulator before he's going to allow you to start to operate or start the facility up is missing. And if you're talking about project schedules and project costs, 1 or 2 delays or a week's delay to project startup because of the lack of information, there is a huge amount of cost involved in that. And having the correct information also improves or helps improve project safety. It doesn't fix all of the safety issues, but actually knowing about having the right information about a facility ensures that, or a class of equipment ensures that, say, for instance, you're lifting. If you're lifting things, you have the correct weight, the center of gravity and all those sorts of things. That aids the safety. side of things. And also during that execute phase, there are a number of additional benefits, and I've just picked on one here, but there's a whole heap of additional benefits in terms of reuse of that data. So we are working under our MOU quite closely with SEIIA, and the reuse of the information that's being collected about an asset does feed quite well into the advanced work packaging, and that actually then again improves project facilities, because you improve your tool time and your construction efficiency by having the right information, making sure that all the information about what you're actually trying to build is there, so that you can actually streamline and maximize the use of your workforce. And then if we look at the operate phase, again, I've only chosen to pick these two out, but actually what is, from the operations manager or the asset manager in an owner operator, what are the top things that he thinks about? He certainly thinks about safe operations. Obviously, he doesn't want to have any catastrophic failures on his facility. He thinks about his license to operate, and then again he thinks about efficient operations. So how can CFIHOS impact that? Well, obviously having a correct and complete set of information about the asset that he is operating enables safe operations. It also supports his license to operate. And the license to operate is also, it's not only about demonstrating compliance to the regulator, it's also having the information and understanding what his emissions are likely to be, because the people are quite concerned about that these days. And in terms of efficient operations, having that correct information. I talked earlier about most owner operators reporting that the large part of their engineering team spend a large proportion or a significant proportion of their time trying to understand and validate information. But if you've got correct information and it's complete, you eliminate most of that. And I suppose last but not really least is CFIHOS is foundational to allowing organizations to achieve their digitalization goals. So CFIHOS is not a digital twin, but it certainly does enable you or organizations to build their digital twin. I would actually offer, if an organization at the moment is building a digital twin and is not building it on standards, I'm not saying CFIHOS, it has to be CFIHOS, but is not building his digital twin based on standards and relevant standards, then he is building something that is certainly not sustainable for the life cycle of an asset. When you think of most assets, their life cycle tends to be in 20, 30, 40, 50 year event horizons, not just your 2 or 3 or 4 or 5 years from a project perspective. So if you're building something like a digital twin and you're not basing it on CFIHOS is one of the standards, it's a foundational standard, but there are other foundational standards out there that you should be building your digital twins to, then you're not building something that is sustainable. Right. I've rattled through that quite quickly. Any questions, comments, thoughts?
Yes. Any questions from the audience? If not, I can ask you a question. As SEIIA as part of CFIHOS, what would you say is the greatest benefit for a SEIIA member in terms of CFIHOS things?
The greatest benefit for CFIHOS is for SEIIA members, I think, is it delivers to you and certainly to new organizations a standardized class library and set of properties against equipment types that are standard right across the supply chain. So it gives benefit to the whole supply chain, not just the owner operator or the EPC contractor. It's right across that whole supply chain, and it reduces the friction in the supply chain, because quite often, you know, the delivery of information right from the very small equipment suppliers all the way up to the owner operators, there's quite a lot of friction, there's quite a lot of churn in that process, and I would like to say it eliminates it, but it certainly reduces that friction in the supply chain. Does that answer your question?
Yes, thank you. We got another question from the audience. I think it's from Ola. Welcome.
Yes, thank you. Hi, I'm Peter.
Hi.
You know that we have been using the CFIHOS standard for quite a while, and I was a bit curious about the development of structures in the context of attributes. I know we have structures in tag classes and equipment classes, but is there any intention of creating structures as well on attributes?
Structures in what respect? Sorry.
For example, we could group overall dimensions. For example, you can have a placeholder for that. So you could group dimension attributes in a group. You could have a group for containing classification of hazardous data, like ATEX data in a group. You could have,
Yeah. Okay. Yes. Sorry. Yes. So interestingly, as part of the next release, we have developed the data model to what we're calling the component model, and what that is the ability to group information together in a structured and standardized way. So that is going to be part of the next release.
I can see a great benefit of develop the maintenance of these groups. You could use the groups to add to a class of an object instead of picking out separate attributes for each component. You can add the complete group instead. So this is something that we are looking into. So it would be nice to have this grouping.
Okay, so what I can say is that we have developed the data model. It is actually it's being tested at the moment. And if you're interested, if you drop me a line, we can actually share a version of it, or I can put you in touch with Jason, who looks after our data model. To talk you through how that component model is structured. But as you say, there is an advantage in terms of, rather than, you know, if you've got a particular group of attributes that are common, and you can attach those to objects, as opposed to, as you say, making the relationships individually. And that's how we've restructured the data model to support that.
Great.
Okay.
Yeah, I'll appreciate it.
Okay, no problem.
Great, thank you.
Yes, thank you. Next question comes from Erik Andersson.
Hello there.
Hi.
Thanks, Peter, for a great presentation, I must say. I'm returning back for a moment to the roadmap circle or wheel, if you wish. And you had one of the slices there mentioning models, and I just want to see if you, while having addressed the attributes and requirements successfully, are you now going a step forward to also address handling journal object metadata, such as descriptions and structuring information? Is that part of the module program or step here?
So what we're talking about when we talk about models here is we're talking about typically engineering models. And what we mean by that is your 2D models and your 3D models that are used throughout the life cycle of an asset or a facility. So at the moment, we're concentrating and focusing on things like what we call 2D models, as I say, things like your P&ID data, your instrument data, your P&ID model, your instrument model, your electrical model, because they define the process plant, and also from a process perspective, things like your process simulation models and your case models and things like that. So that's our focus at the moment. We're working very closely with USPI and their 3D modeling development that they're working on. They're working on a program for that. And ultimately what we want to do within CFIHOS is, under the MOU arrangement, is to point to USPI's definition of a model and a model handover, as opposed to us having our own. But at the moment, we're predominantly concentrating on the engineering models.
Right. Okay. Thanks. You probably see what I mean, but just to make sure that it was correctly addressed. What I'm looking for is the ability to have a common language of exchanging information to build a facility structure up, like the addressing the different aspects of, for example, the IEC 81346 standard, having the functional structures and the locational structures and such things. But maybe you got me right there, but could you please elaborate a bit about that?
Well, we're looking in terms of the structures within those models. We're looking to others for those. So we're looking for other standards. So if we talk about the P&ID model, we're looking for DEXPI to define that structure and that breakdown within their P&ID exchange. But equally, we're aligning in terms of classes and properties that are in those models.
Okay, great.
Yeah.
Thanks.
Mm-hmm. Okay.
Yes, thank you. Another question from Paul. Welcome. Paul?
Muted.
You're muted, Paul.
Sorry, now it should be better. Can you hear me? Okay.
Yeah.
So my name is Paul van Exel. I am with USPI for many years, and I'm also convener in the industrial data group under ISO. I would just like to add some information to the discussion on the attributes. In 1596 Part 4, we have agreed to simplify the properties by applying a model which actually dates from 1999 to work with a base property and property qualifiers like top or bottom or minimum or maximum, that kind of thing. And we found that if you do it that way, then whereas today many properties are concatenations, we can reduce that maybe with a factor of 30 by doing that. And I have understood that CFIHOS are going the same road. So that would nicely add to what the other speaker was saying about grouping them into useful groups so that you can manage them easier. That would assist in that process significantly, I think. Maybe Peter can confirm that.
Yeah, sure. I can confirm that. So part of what we're doing with the property groupings is to enable that. So it's a sort of like a first stage approach to it, rather than having specific, you've got temperature, you've got highs and lows of those temperatures. So rather than having, a specific property that is, operating temperature max is a property, actually what you've got is you've got a temperature which is in degrees C, and then, as you say, you've got a qualifier that is maximum, and then you've got a minimum, but actually your property is temperature. So yes, we are going down that route, Paul.
Okay. Yeah. Okay. Thanks.
Thank you. Any more questions from the audience? Yes, something. Monica, welcome.
Yeah. Hi. I just said that I'm really pleased to hear that CFIHOS is moving that direction, because that really fits much better into the work that we are trying to do, to go into the base attribute and then have qualifiers to do it. That way you can structure your model in a much better way. So I'm really pleased to hear that CFIHOS is going that direction.
Good.
Good. Anything more? Otherwise, we send a big thank you to Peter for interesting discussions and also for a nice presentation.
Okay. No, thank you for your time.
Yeah, thank you very much. And if those of you want to be in contact with Peter or CFIHOS, just give us on SEIIA a call or a mail or something, and we will forward that onwards. So everybody, next on stage is old friend of us, I guess, isn't it, Erik?
Yes.
We say welcome to Love.
Hi, Love is back here, and I'm going to talk about problems, because I know that you out there, you are problem solvers with one goal: helping the world, the environment in the companies. As I know, has been like most companies have some kind of problem to solve every day. And this problem could be a small problem. Sometimes it's a big problem. Sometimes it is only you who take care of that problem. Sometimes you need to be a group taking care of that problem. But in the end, you solved it. Okay. So that is lived in Sweden for many, many years. Now I hear disturbing rumors from some places around the world. And that is, they have not just one goal to solve the problem. You have to also make your problem the competitor's problem by doing this. So I say not very kind, but the competitors, they have also employees that can solve problems and perhaps can make it disappear. So the goal for someone is to make this problem permanent for the competitor. And I say, not kind at all. That's what I know that you out there, you're the good guys that have this one goal to help and do everything better. So perhaps I see you one more time today. Bye.
Yes, thank you, Love. And now we're heading for a short break. So please take your time, stretch your legs, grab a cup of coffee, and we'll meet you back in 10 minutes. Keep an eye on the clock on the screen, and when that's 0, we start all over again. So thank you for now, and we'll be back very soon. So, welcome back, everybody. Hope that you got yourself some refreshments and that you're alert to join the rest of this evening. Next on stage, I will welcome Henrik. Are you with us, Henrik?
Absolutely. Can you hear me?
Yes, we hear you. So I would say the stage is yours. Welcome.
Thank you. Let's see if I can share my screen and get this started. Let me know if you can see my screen coming up.
Yes, but not the presentation view.
Okay, it's not in presentation view, and let me let's look better now.
Yeah, now we're in the presentation mode. So once again, welcome, Henrik, and the stage is yours.
Thank you so much. So always tough to go after a wizard, but I'll try to do my best. So let me start by introducing myself. I assume that there's quite a lot of people who doesn't know me from before. So my name is Henrik Wikberg. I'm located in the southern part of Sweden, just outside of Malmö. And today I am the Vice President of Global Sales at a tech company called Intelecy. I've been working with this company for 2 months now, so kind of new there. Prior to Intelecy, I was the EMEA lead for manufacturing at AWS. So basically looking into how to use cloud computing, AI, ML towards manufacturing to kind of digital transform companies to be more data-driven. And prior to Amazon, I was at SKF. I was responsible for their team that was basically deploying digital technology to transform the manufacturing to be more data-driven as well. So that's kind of my history, going all the way from end user to IT and cloud provider, and now to more kind of a software-driven company. So when we talk about digital transformation, we need to start to look at kind of the history and how this can affect the business we're in. And this is kind of a famous slide that shows a little bit how business transformation in general, specifically now when we talk about digital transformation, how it can affect the business. So if you have a mature business, you have key players, you have up-and-comers, but you usually have a very steady business where not a lot of stuff happening. And suddenly something happens. You might have a change of business model. You might have new technology coming in. So there's a strategic inflection point at a certain time and period where a lot of stuff in the industry change. And basically after this position, you need to adapt according to the new laws and the new situation within the industry, or you will diminish and die. We've seen this many times in different kind of businesses where you have this strategic inflection point, something changes, and you have big key players basically fading away and becoming more marginalized, and you have new players coming up and really taking the center stages with this industry. So just to talk about a couple of failed businesses, obviously we have Kodiak, who was the biggest one within photography. And then we have digital photos coming in, and they didn't transform according to the industry and basically went bankrupt. The same for Nokia with their phone business as the iPhone came in, and you had a new kind of interface, and Nokia was too slow to adapt and didn't manage that transformation. Obviously, Blockbuster is more of a US-based company, but the same there. And obviously, these are sad stories about large enterprise going out of business. But on the flip side, we have new companies coming in and basically becoming the global players. So obviously, if you look at the fall of Nokia, we had the rise of Apple and the iPhone. With the fall of Blockbuster and similar companies, we have the rise of Netflix. And also, if you look at the entire CD and DVD story, as Spotify came up with streaming music, that kind of industry went that as well with all the sub-suppliers that was in that industry. So the summary of this page is basically that if there's a transformation going on, you need to adapt to survive, or you need to adapt to maintain relevant within that industry. You can't sit by and wait forever and just do business as usual as you've done before. And that's the brutal truth about business transformation. And I think this is also coming back to the urgency of Industry 4.0 in manufacturing, and why it's so important to start adapting towards it. So looking into a couple of famous quotes from a couple of famous people. So this is Jeff Immelt. He used to be the CEO of GE. And way back in the days, I think this was back in 2016, 2017. No, sorry. This was probably back in 2011, 2012. So he said basically, if you went to bed last night as an industrial company, you're gonna have to wake up today as the software and analytics company. And that comes back to the entire mental model of Industry 4.0 and having the insight of data to drive and change the daily operations on the shop floor. And I must say that, you know, this quote was made very, very early, but I think we see a lot of transformation out there in the industry where companies are at least trying to make the switch to be more data driven on a daily basis on the shop floor. This is another famous CEO, so it's Tim Cook of Apple. And this quote goes more towards how you consume products. So he said that the lines between software, hardware, and services are blurred or are disappearing. And it goes back to a little bit how we today consume products. So in the consumer industry, it's been quite a while since we stopped buying CDs and start a subscription on Spotify instead. Stop buying DVDs and movies and started a subscription on Netflix. So that kind of servicification has been there for a while. And this is something we see now in industry as well, where you, instead of actually buying something, you actually lease it. And both within IT and with OT. So if you look at how you buy compute power and software, but also how you might buy or lease a machine instead of buying it. So this is also a kind of a transformation we need to look out for and understand how it inflects or can infect and improve our business opportunity. And also, besides the business opportunity, of course, we have the sustainability aspect of it. So looking today, we have 30% of the world's greenhouse gas emissions being contributed by manufacturing. Manufacturing is also responsible for 30% of the world's energy consumption. So we can definitely see that manufacturing as a complete industry basically carries 1/3 of the pollution we see and the emission we see throughout the globe. And at the same time, we have an average efficiency of 65%, which means that even though we've been working very hard and diligently on trying to be more effective, there is still room for improvement going forward. And I definitely see that digital component can help us be more efficient in the future in manufacturing. So now we have basically, two main arguments for digitization. One is that if we don't do it, we won't be competitive in the future. And we also have the fact that we need to bring out greenhouse emissions to make sure that we can live on Earth for a long period of time going forward. And this comes back to a little bit how we use data to run our manufacturing operations. And the notion about Industry 4.0 is basically to bring big data from the shop floor and use that data to create value. And I usually define this in kind of a 4-step. And each step is extremely important to be successful. So the first step is the business outcome. So we need to understand exactly what we want to achieve with the project, with the initiative, or with the data we're collecting and utilizing. This is usually done by the factory personnel who basically write the narrative that states the opportunity and what they need to be able to address that opportunity. As we go to the next step, we need to go down to the shop floor and look at the actual process that we're targeting. So usually what we do in manufacturing is that bringing data from the shop floor means that we need to start pulling data from the PLCs, the DCS, the SCADA system, MES system, or LIMS system. Wherever you can find data that is relevant for the business case you're trying to address, you need to start collecting. And this might sound easy, but it's not really that easy in manufacturing, where you have a lot of different industrial networks. You have a lot of suppliers who bring in proprietary technology, different industrial interfaces, and no standardization on the application layer, which means that for each system, each asset you connect, you need to understand the data model that comes off that specific machine. And that can be a task on its own. After this, we have the connectivity part. So today, a lot of software, a lot of services run in the cloud. And we also have a lot of software and services that can run on the edge as well. So understanding how to adapt your business case and your data modeling in the scope of how you want to solve this towards the existing network and IT infrastructure can be quite complex as well. And if you're looking from an enterprise perspective, you usually have a lot of factories, you have a lot of networks. And if you want to be scalable and be cost efficient, you need to come up with a solution that scales, that works with other factories, and you can reuse the solution going from shop floor to shop floor. And then the third step from a technical perspective, bottom up, we see kind of the ML ops, the data ops, and the analytics. So this is basically where we use tools to look into large data set and turn those data points into information and knowledge, and then use that knowledge to reconnect back to the business case that was scoped and change processes, adapt processes, change programs or parameters to actually tweak the manufacturing to address the business case that we targeted. So these are kind of the 4 steps that we need to go through to be successful with digitization on the shop floor. And as you can see, I would say that you have 3 different kind of department or personas that comes into this. Obviously, you have the SMEs and the engineers that understands manufacturing. Then you have IT personnel, data scientists, data engineers. You have networking experts that basically build the 2 steps in the middle with connectivity and data store analytics. And business outcome is usually defined by line of business people, either from the shop floor or from central operations team. So there's a lot of communication and alignment that needs to go on to make one of these kind of projects successful. And that brings us over to the complexity of digital transformation today on the shop floor. So to understand how one of these projects are deployed, first we need to bring the knowledge from the shop floor together. And this is usually presented by the process engineer if it's a process issue, the quality engineer if it's a quality issue, or a maintenance engineer if it's a maintenance issue. Or it's a combination of several engineers to define the root cause of the problem and define the business case and the opportunity for the company to save money or make money in the process. As we come to the problem and to address it, and when it comes to data and communication and network and machine learning analytics, usually the competence sits within the IT organization. So we're looking at a digitization engineer, usually is kind of the bridge between the factory and the central team. We have the data engineers who basically cleanse the data and build a data set that is useful for the data scientist to use. And then we have the data scientist and the programmer who can take that large data set, cram that into an algorithm, take that algorithm and bake it into to a container or some kind of software runtime that can then be deployed on the shop floor. And obviously, to be able to do this, we need some kind of technology platform, which is usually kind of do it yourself on a cloud provider such as AWS or Azure or Google. And to be able to maintain and manage all of this, obviously, we need some kind of PMO, some kind of project management office to do this. And usually, as we're looking at very different organizations, usually we have a project manager from the OT side, and we have a project manager from the IT side. So my experience is that we usually end up with a team of somewhere between 6 to 12 people to run these kind of AI/ML projects in manufacturing. And if we're really quick, we can see a kind of an 8 to 12 weeks of iteration time. And when I say iteration time, what I mean is that as you start defining the use case and you have it defined, you start putting the team together, you start understanding and collecting data, you start running your ML ops, and you create the runtime and you deploy it back to the factory. That is usually at least 2 to 3 months time. Historically, you're not successful with your first model, so it needs to go back and forth a couple of times to be able to train it as well, so it can actually bring business value to the shop floor. And this is kind of an expensive and slow process, as we're usually looking at least 6 to 12 months to actually have something running in the factory that may or may not bring actual business value. And this comes back to a little bit about the problem and the promise of Industry 4.0 to bring productivity through data insight. So what we see from hard fact is that close to 40% of all manufacturing companies, industrial companies, have tried to solve business issues or manufacturing challenges through AI/ML. The sad part is that 85% of all AI projects fails. And with failing means that the project were not able to bring business value to the problem that they were trying to address. 85%. That's a pretty high number in terms of failure rate. And 51% basically due to the failure is the lack of skilled talent. So obviously we have quite a few people coming together to be able to run these AI projects. And be able to find those talents, it's not necessarily easy, and it's not necessarily cheap if you actually manage to find them. Second reason was lack of access, technology and tool. And the third one was access of useful data. So actually having the data that can be the base to build those kind of models and use it. And this comes back to basically why Intelecy was funded and what our vision and goal is to do. So our goal is to kind of address the lack of skilled talent, the access to technology, and the access to useful data. So what we're trying to do is, number one, bring away more or less 95% of the need of resources into these kind of projects, number one. Number two, what we're trying to do is shorten the time of iteration from the first model has been built to the model has been, let's say, I wouldn't say finalized because you can always retrain them based on new data, but fine-tuned to a level where it brings business value and it's productive for the shop floor at hand. And this is through what we called no code. So instead of using data engineers, data scientists, and developer to generate these models, you actually use a software tool. And this tool is targeted for the factory personnel. So perhaps the operator or the production manager, if you're looking at a production issue, a process engineer or an automation engineer, if you're looking for a process problem, or a quality engineer, if you're looking for a quality problem. And I think this, having the reduce of manpower to be able to do this is obviously very beneficial. But I think the time of building the model and iterating on the model is even more important. So today, to just give you kind of a short view on how this is done is, first you need to have somebody who draft the actual business case. He needs to understand the process. Then you need to have somebody who actually defines the data model and start collecting the data. There needs to be somebody who understands the process and have knowledge of networking and IT infrastructure. And then we have the data scientist, we have the Python libraries, we have the data lake where we store things. There's a bunch of custom integration that needs to be done between different IT systems and business systems to make this happen. And as I mentioned before, we need to iterate several times to get these models to provide value in the shop floor if possible. And if we manage to do all this, we get a snapshot insight of one defined business case. It's not a continuous learning, and it can't be adapted to any kind of process. It's just for this specific process and this specific problem. And where we want to go to, and what Intelecy is working with, is basically that you need to have knowledge of the process itself. and you have a no-code AI software tool, like the one we provide from Intelecy, and you get continuous insight into the operation for whatever business case you're trying to solve or address. And I think just if you look at how improvements are done on the shop floor today, we see that there's much better alignment with the continuous insight than if you get a snapshot insight. So even if manufacturing has been through radical change since, let's say, the 1970s and onward, I think that we see that the majority of the different production systems out there are based on one principle, which is the continuous improvement, small incremental continuous improvement to make the production better. And if you go in and look at the Six Sigma mentality is that you define, you measure, you analyze, and you improve, and you control if you met the targets of the improvement. And then you recycle this over and over again all the time. And the way we usually run MLOps today, it doesn't really adapt to this. It's always project-based, it's resource intense, and it's the snapshot insight, and it's a ton of communication that needs to go through OT to IT and back to OT to IT to be able to address these problems. Instead of actually providing the tool to the ones who operate in the shop floor, who can use this tool as a continuous tool on their daily work. And that comes back to the biggest change, I would say, that the no-code AI/ML software solution is adapting to the way that process improvement, the productions improvement, and quality improvements has been done for decades now, where AI/ML ops that runs in the historical way doesn't really adapt to it, and it's too slow to actually bring value over time. And I think this is the key issue that we see. Even if you have the money, even if you have the resources, it's really hard to be successful in building machine learning models that can improve the shop floor over time. And from Intelecy, we think it's more of a culture and organizational issue than a technology issue to be successful. And historically, we say that if you throw enough money on the problem, you will solve it. But I think we see now, basically, I would say 12 years since Industry 4.0 was instantiated, we see that throwing money on this problem doesn't really solve it. A new approach will solve it. And we definitely see that this no-code software platform is the way to go in the future. So I've been in manufacturing now basically since I started my career back in 2001. And I've been working mainly with industrial automation up to, I would say, 2014. From 2014 up till now, we've been very much around digital transformation and how to do things differently and use data within industrial automation to address the issues we have in manufacturing. So I come across a lot of problems, and I learned a lot through the journey. And on a high level, I basically want to put this together and from a strategic perspective, talk a little bit about the problems and about the lessons learned. So I think the first thing is that the digital transformation of manufacturing has just started. Absolutely, we've been at it basically since 2011, 2012, perhaps, and even before that to some extent. But as I go around in the industry, in US, in Asia, in Europe, we can still see that a lot of companies are only on the starting of this journey. So I don't say we're late to the party. It's absolutely urgent, and we should address this as soon as possible. But the journey has just started. And in the beginning, I would say that we spoke mainly about technology. It was about cloud computing, it was about AI/ML, it was about connectivity and IoT. And everybody was zeroing in on the technology piece. I think now we learned that transformation doesn't start with technology. It starts with education, organization, and cultural change. Technology can't work without education to understand and use it. and the organization and culture won't move with you if you haven't prepped them for it. No technology in the world can change this. So transformation always starts with education and organizational culture change. However, coming back to technology, obviously technology is important, but it's not just to have the right technology. It's about standardization. A lot of companies, or I would say any company, can't afford to buy technology differently from site to site, country to country, region to region, etc. We need to find a technology standard. We need to build the education and the organizational culture change based on that. And we need to be able to reuse it on all other places. This goes from different tools to different data sets, models, and communication interface. It needs to be able to be reused to be financially viable. And this comes back a little bit to two words that are very important in digital transformation. It's scalability and repeatability. If you buy a technology that can't scale, that can't go to several factories or several users, it can only work for one country. You're kind of accepting to buy the cost of that, but the big cost when it comes to digital transformation is not really to buy the technology, but to maintain and upgrade the technology. So you have to look at the life cycle cost of the system that you're sourcing, not just only the licensing or the purchase cost. And here we also keep coming back to standardization, making sure that the tool fit for all the different sites or entities within the enterprise is extremely, extremely important. And as we talk about technology, it's not only about what it can do, it's also about who can use it. So if we look at, there's a bunch of really cool technology out there, and coming from AWS, we were very proud of a lot of the AI and ML solutions we built in the cloud and enabled for our customers. But those customers were usually developers and highly educated personnel who didn't have knowledge about the manufacturing process, which obviously gave us that issue about the IT/OT barrier and having problems to make them develop something that could be used by the shop floor. And I think this is why we start seeing a trend of vertical solutions, where we have specific user-friendly tools that are adapting to a certain target group on the shop floor to be able to use their tools to be able to bring business value in a much more direct and simple fashion than if you basically do the ML ops that I've been talking about earlier. So really about focusing about the simplicity to deploy and use these kind of tools. And also digitization is not a project, and it's not something that you do and get a check in the box. It's a journey that kind of needs to go through the entire organization to be successful. We need to kind of change the way we're working and have data and information as a component and on a day-to-day basis gives us a better opportunity to be more efficient the next day, after the next day, after the next day. And that's kind of the end game of digitization. Independently, we're looking at who's the supplier, who's the user, and how do they do. The question should always be, are you bringing and visualizing and understanding data more today than you did yesterday? And are these data points changing the way you do your work on the shop floor in a better way? If the answer is no, then we haven't really succeeded in our digitization journey. If the answer is yes, I understand my process much better today than I did yesterday, and I actually do my work in a different way today than yesterday, then we definitely have to kind of change the culture on how we work. We've been able to integrate the data as a core component in the Six Sigma and Kaizen workflow that we always been working with, our production system. And on the bottom line for the company, I bet you that we can see that we have a positive impact on on the bottom line of the result. And to be able to do this, believe it or not, we need top management buy-in. Usually what we see is any kind of technology that should be standardized, there's somebody sitting high up in the organization who needs to have a budget, and he needs to give it to us so we can spend those money and transform the company. And to be able to get this kind of money, they need to understand exactly how this investment will pay back. And this comes back to the business case with the slide on top. When we're talking about digital transformation, there's a lot of talk about technology. But as I mentioned, it's not really about technology. It's about making or saving money, and it's about education, organization, and culture. Technology is just one tool that comes in to being able to do this. But we should never kid ourselves that we can start doing a company-wide transformation bottom-up. We can absolutely do proof of concepts and pilots, and we can absolutely change the way how a factory works. But be able to standardize that and drive business value with that kind of architecture throughout an entire, let's say, entire enterprise with global manufacturing footprint, we need to have top management buy-in. And that's always where we should start to make sure that we get that before we start on the journey. And that's the last slide from me. Just as kind of an end, what we do at Intelecy is that we have a software platform where we provide connectivity to the shop floor, as well as a no-code interface to build machine learning model and to deploy and activate them towards the shop floor. So you can get those ML models basically as a closed control loop on top of your PLC, SCADA, DCS system that manages the shop floor automation today. Happy to take any kind of questions and queries. Feel free to add me on LinkedIn if you want to get a shout out and discuss data transformation in the future. Thank you.
Thank you very much. Really nice to have a opportunity to listen to you. Do we have any questions from the audience? Henrik. Applause and thumbs comes up. That's good. Listen to Henrik. I think it start to happen things in people's mind, and I'm just curious, is it somebody in the audience that can share any thoughts if you don't have questions? Paul, please, welcome.
Yes. Yeah. Good afternoon again. I thought it was a very interesting story, and I compared it with the thing I learned quite some time ago when I worked for Shell. We were so lucky to do a training course of a few weeks on how to manage major changes, and we learned what we called the change equation, which said the change you wish to achieve is a function of the shared vision, the pain with the current situation, the capability to change, and there was a fourth one, and that was the interesting one, the view on the immediate next step. And listening to the presentation, I recognize the vision, the top management. If that is not there, then people will continue to move in the direction where they want to go. The pain, I suppose, is where you feel that competitors are maybe growing fast because they do new things and you're not doing it. That hurts. The capability, that is, I think you addressed that also quite well, because you have the technology side, but also the culture and the education. But the last one, which I personally think is a nice one, because it says, if you know what it means for you yourself, what you would be doing next Monday helps enormously in achieving the change. And do you have any idea about that? I'm interested to hear that.
No, absolutely. Absolutely. So that's that's a really nice story, and I completely agree with everything you say. And I think one of the reasons that a lot of AI/ML project fails is exactly what you pointed out. Let's say the personnel on the shop floor that are or should be mostly impacted by this project are usually not really connected to it. And they don't really understand how their work should or would change with the solution in place, which is kind of interesting. It's basically when you're doing a job and somebody has this huge project on the sideline, and then he's saying, you should use this tool and this should be great for you. That's not usually the best way to get somebody to use a new tool, understand a new tool, or make business value with that new tool. So I think that's also what we see in Intelecy, because we never address that large kind of audience. We talk to the quality engineers if the company have a quality issue, and we usually stay there. Obviously, we talk to IT to perhaps use an open firewall port and get to the cloud platform that we built and get back with kind of the ML models inference data. Absolutely, we do that, but our main target audience are the ones on the shop floor, which means that they are the ones who engage with us, and those are the ones who will get benefit from the engagement, and those are the ones who will use the tools going forward. And I think that's a lot of the reasons why these ML projects fail historically. Whoever works on them are too far away from the actual operations. Really appreciate that information.
It's interesting that two totally different worlds, because that was way before computers were even used. That it aligns so well. Thank you very much for that answer.
Yeah. Thanks. Obviously, there's no dumb questions. Any kind of questions, it's interesting.
Yes, take the opportunity and send a question now. Anyone? No, doesn't look that way. In that case, we want to thank you very much for attending to this. And yeah, if somebody have any questions, they can send them to us and we can forward them. If Henrik, well,
I'll be here.
So once again, thank you very much. And then I let the next person on stage, and I think that will be Love again. Welcome.
Hi, Love is back. And before you start the serious talk, I would like to show you something who actually made me the first person in the world winning an internet magic competition a few years ago using these. And these are named to be one of the most beautiful coins ever made. And I don't think so many in America knows that it actually was an imported Englishman from Great Britain who designed these beautiful coins. And I'll tell you now, you're ready for some super small illusion. We got $3 coins. We still have 3, but one jumped, and I think I can go a bit. Come on, you got another chance. Still 3, they're jumping. Let's go for the Swedish waterfall, $3 coin. We go 1 like that. Here we go. Number 3. The problem here, ladies and gentlemen, is that you got 2 eyes. This is $3 coin. Let's remove 1. Let's make the odds on your side. So let's just use $1 coin. And I know that some of you are thinking, can Lube do something fun with just 1, or does it have to be 2 or 3? Well, to be honest, it's so much more fun if you have 3, because then you can take 1 and make it disappear. And if you have 2, you can make that one also disappear. And if you just have 1 and very short sleeves, you can make that one disappear. Let's go for the final little touch. I tell you, not someone, everybody says when the $2 jumps, here comes the 3rd. No, here comes the poker chip. Yes. Now, I never gamble with money. I have too much respect. And you know something? It's cheaters out there. So, if I was really forced to play, you know, I will make them lose. Yeah, I would. If someone give me 2 for a tip, I will make one to $1. Then I will take the other one, make it also to $1. Then, in the end, I will make everything just disappear. And that was everything for me. But I will see you a bit later today. Now, it continues the serious talk. Bye.
Thank you for that, Love. Next on stage is Monica. Are you with us, Monica?
Yeah, I'm here. Can you hear me?
Yes, we hear you clear. So I leave the stage for you and want to wish you very welcome for this evening.
So can you all see my screen now? Hopefully in presentation mode.
Yes, in presentation mode.
Yeah. So just a little bit about myself first. My name is Monica Hula. I work in an EPC contractor company called Aibel. The things that we normally build and construct.
Excuse me, Monica. I think you're not in presentation mode.
Okay, then I will.
Swap it, please.
If I manage to go there. Can you still hear me?
Now you're in presentation mode. Sorry for that. And please continue.
Can you hear me now?
Yes, we hear you.
Yeah, it's just because I'm in the meeting room and I had to disconnect from the meeting room system, so I got to go back to my my computer. I'm Monica Hula. I work in Aibel. We are an EPC contractor, and we engineer, purchase, and construct oil and gas topsides and wind converter stations and hydrogen plants. That's our main business activities. Myself, I worked here for almost 20 years in the engineering arm and in the system engineering part. Our vision when we started the work of digitalization is that we want to move from a document-based deliveries to data-centric deliveries. And since I work in system engineering, the documents that we produce is typically process block diagram, process flow diagram, process and instrumentation drawings, piping and instrumentation drawings, and data sheets. And we want to move over to the right side, to something that's computer readable and not just a picture, because the traditional PFD documents are just a picture. To give you an idea of how many such documents we produce in a project, typically it's 50 to 100,000 PDF documents produced in a project that we have. So on the number of documents in these flow diagrams and P&IDs is usually maybe between 250 to 300, which we issue typically each of them maybe 5 times, just to give you an idea of where we are. So that's like our vision. We want to be able to share not only on those 5 issues, but we want to be able to share from day to day. And we want to be able to do the work with producing the information in a smarter way. So in system engineer, we work in a top-down approach. That's our base way of working. We start out with a field block diagram. So let's say we have a hydrocarbon resource, in our case, most frequently in the North Sea. And we're going to convert that into something that we can sell, a gas at a specific quality and liquids that we can sell at a certain other quality. And then we decides after that, we are looking at how many different systems do we need to do that, and what kind of systems are we going to do. So that's the way we are thinking when we do this work. And I try to show you the VIDE model of engineering work. So we start with a concept design when we have process requirements and constraint. And that's when we do the front engineering and design. And then when that has settled down, we move on to the next stage. We go from conceptual design to detailed design. And then we say, what kind of equipment can we buy or build that will do the things that we want to do up here on the upper left side. And then when we have decided exactly what we're going to need and what kind of requirements that should follow, we are buying them. And then we start on the journey back. And then we get all the construction drawings that the layout design can implement and create a facility that is possible to construct. And then after it's been built, we go back into testing modes, and after that, even you go into operation of a process plant. So then kind of you are back in the system world, whereas down here you are in the equipment world. And we have let ourselves be inspired by the IMF because it uses aspects to separate function from equipment. And here they have an example of a pump, which is you have the functional system and breakdown structures. They are typed by activities. We want to do something. Okay, and here on the product thing, then we specify what we are going to do and how we're going to do it. And then we're going to say where are we going to do it. So that's kind of the IMF inspiration that we've been building our work on. And there is a gap in the standards because I don't know if the audience is used to reading process flow diagrams or block diagrams, but to give you an example, it typically contains symbols of, let's say, a pump or a distillation column. And many people think that represent the actual pump or the actual distillation column, but it only represents it indirectly. It's intended to come a pump sometimes in the future. So the symbol actually represents a system that is going to perform an activity, a process. So when we are doing the design, we need to look at the process requirements, the constraints, and what kind of systems we can use to fulfill those constraints and requirements. And so we are not looking at a specific physical equipment. We are looking at the system that can separate by distillation, or we are looking at the system that can transport the fluid if in case of the pump. And the system is always more than the actual equipment. It's the entire thing you need to have in place in order to make a distillation column do its work, basically. And then I'm going to talk a little bit about another way. There is another gap in the standards, and that is we can break down the systems in hierarchies along the aspects. And we can use the functional aspect in ISO 81346 to define the system for DEXPI+. The DEXPI Plus has since been rebranded to DEXPI Process, so sometimes in this presentation I will use DEXPI Plus and sometimes it says DEXPI Process. And this product aspect can be aligned with existing equipment-oriented standards. And we have like the functional, that is what is it that we are going to do? Separate by distillation, for instance. And then what are we going to do? How are we going to do it? Well, we're going to use a distillation column with its things arranged. And then we're going to specify exactly what we're going to buy. And then we will, after that, in the purple sector, you will have the built the actual artifacts in the plant. That's the asset structure. So it starts out with the process step, and then you start with the facility design, and then you have the asset specifications. And at the end of the green side, that's when you actually have an equipment, not just an intended idea of what you're going to build. And just to say that the process flow diagram is firmly in the functional requirement side. The traditional P&ID is firmly in the product aspect. So actually all the way over in the green side. So there is something in between the blue part, which is not there today. And we have the standards landscapes, and we have the existing DEXPI standard, which is for the P&IDs, and we have CFIHOS, we have ISO 15926, we have various NAMUR standards, and we have asset, and they all have one thing in common. As you can see, it's on the lower right corner. It's about the products. It's all like focused on equipment, whereas the design, the system design bit, the process design, the process structures, and all of that is outside the standards landscape. And since that's lacking, we've been working for a while together with the International Digital Twin Association and the DEXPI organization to put together a new standard called DEXPI process, which is a standard for modeling the process and its diagrams. So this is just an example to the left of a typical block diagram and a typical flow diagram, just to give you that is what we are. So trying to do that. And there is another way of looking at this. So we have the functional side, which is the design specification, the functional requirements, and the function. And based on that, you kind of have the functional decomposition, the block diagrams and the flow diagrams, which is something that you could model in the DEXPI process structure. And then you have the behavior information model, which is the traditional simulation tools that we are using, like HYSYS or Olga or FlareSim. I'm just mentioning a few. There is a lot of them. And the thermodynamic models that we base our work on. So what we need from the interface between the information model of the process model and the behavior models, it is the stream tables with the states at the various places in your desired process design. And then you have the blue sector, which is the plant structure, where you find the P&ID covered by the DEXPI standard, and then you have the piping and equipment specification, the operational list of properties and device list of property, formerly known as data sheets. There you have the CFIHOS model or the asset administration shell model, and also the 3D modeling tools is there. So that's kind of a new world that we are trying to put together in one square so we can share information between the various tools that we use in our work. So we have been inspired by the IMF objects and system thinking. We have the main process system, the technical system, the component system. And the technical system is, the main process system is that we need a facility that can take the reservoir and split it into a product that we can sell. Reservoir fluids into something that we can sell. The technical system is that we're going to need a separation system, we're going to need a distillation system, we're going to need some pumping system or a compression system, maybe we need a drying system, and etc. etc. Maybe we need a system that can transfer heat or remove heat. That's the technical system. And then the component system is for instance, that it tend to do separation by gravity or by distillation or by absorption columns or whatever we choose to do, or if we want to use another technology. And the traditional documents that we produce, see if I can manage to, can you see my pointer? No. Sorry about that. Yeah, now can you see my pointer now? Yeah, those three here is the traditional one. It stops there. But we want to move our inspiration for making the DEXPI process standard is to enable us to produce the product aspect that is the traditional P&ID. So every object on the traditional P&ID, we want to, it usually has a reason for being there. In addition to the distillation column, you need instrumentation to monitor it, to control it. You need safety instrumentation. You need maybe heat. You need cooling, and you need maintenance access. You need maintenance draining and all of those things. So the idea is that you will, everything that you need that result in something on your P&ID, you have to specify it. So it's the component and support system. This last step here in DEXPI Plus is to be the starting point of the assemblies that you're going to see on the P&ID. So on the assemblies, when I say that, you can imagine that if you have to have a drainage function, it's just not one thing. It's a piece of spool piece, it's some valves, it's a spectacle blind, etc., etc. And if it's a control, if you need a control system there, a control function, you need a measurement and you need a SAS system that can do something with a measurement, and you need something that you can regulate to control it. So let's say a control valve. So that's the product aspect. And then after, and then you can envision that in the DEXPI standard for P&IDs, which would allow the operator and everybody access to the intended design. And then afterwards, once the project has finished, it would have show the actual installation as it is out in the field. So some background on our modeling approach. So we are trying to do work in the asset information modeling of systems. So we have a system and we have requirements and we have products and product model, we have a process model, and we have the installed module. And in order to make that work, we need some common things like change management, let's say identifiers or metadata to the information that we have inside the model. We need to know where the information belongs, to which project is it. And it's important to realize that the information model is not so good for the human. So you need a way of producing a view that the human can use, utilize the information model in a sensible way. So in the start, our intention there is to go for the traditional. We want to be able to produce the traditional documents from it, but I am pretty sure that as we started work, these traditional documents content will be changed in time. And then the DEXPI process core objects, it's the process step. That's what we want to do. And that is a functional block, and it has ports, and it has different kinds of ports, illustrated here by material port, which is the fluid port. So we can have something coming into the step with a certain state and something else going out of the step with a different state. And each of those ports and streams will have a template of the fluid they represent and the thermodynamic model they represent. So you wouldn't have the same template for various fluids. So a utility fluid would be a different template than your main process template would be. And you can also have energy flows. So you have energy ports with typically electrical energy or thermal energy or mechanical energy. And similar, where you have information type of port where we would exchange information for monitoring or control or actuating information, controlling the process. So we have a hierarchy of process steps. So what must be done? These are things that happens. It's not things. It's conceptual things. What must be done? Separate, transport, compress. And then that can be done by the use of unit operations. And what must be done and how? So then we are over to separate by distillation, transport in piping, compressed by centrifugal motion, heat transfer, etc., etc. So I'm not going to list up all the names, but that's the typical activities that we have. It's not that many activities that we do. We just implement them with different things. So here I just another way. So we have the functional requirements. So that's the process description. And then we have a simulation of what states we want to achieve. And then we get the process flow diagram without saying what technology we're using it, just what state we want to achieve and what steps we want to do to do that. And then we will move over to the functional design. So then we can produce, then we choose that we will have a centrifugal pump or that we will have a gravity separator or a cyclonic separator or a distillation column. And then you have a specific state with that kind of component in your mind. And then you can produce the operational list of properties that is describing the function of the equipment. So then you will have a PFD that has a symbol that represents the technology that we intend to use. And there will also exist a 3D model of the conceptual design. It will not contain a lot of details, but it will contain all the main equipment and where it is in relation to each other. And then we move over to the equipment design phase, and then we will have not only know what the equipment is, but we will know what is around the equipment. And the 3D model will be expanded with all the things that is around it and all the requirements also coming from the layout side at the functional area. And then you have the actual technical specification of what you want to buy. And then you can ask various vendors if they are able to produce what you're asking them for. And then afterwards, you will procure it and you will install it, and then you kind of hand over that information to the end client, the operator of the facility. So now I'm just showing you a typical example of how the DEXPI process information model would look. So there is on the right-hand corner, there is a traditional flow diagram, and on the left side, I show all the various blocks that represents all the things that happens here and their relationships to each other. And what we try to do with the DEXPI process standard is to integrate the existing standards. We want to integrate the SysML onto CAPE. CAPE is computer-aided process engineering, the IEC 81346, the DIN 67979, the NPRO, the READY project, the IMF, the DISC, and the IDO ISO 15926 Part 14. So this is what we have tried to do. We try to use blocks with ports. We have process steps and aspects, and we have a life cycle with clear distinction between process, plant, and asset structure. And there is a set of activities that can be used to characterize the process blocks. And there is a system engineering approach with aspects, technical system and component system. And there is a breakdown for process engineering. And it's possible to link that to the reference designation system for oil and gas that the READY project has produced. And the IMF information modeling framework and the NOACA or DISC collaboration. So we have produced a library of objects for modeling processes and equipment that we have aligned with 81346 DEXPI and CFIHOS. And we have used it on an application to modeling the Munin platform, which is a part of the Yggdrasil development in the North Sea. We have also started doing the same now for a Snøhvit modification work in the north of Norway. And we also have an open demonstration of method with a Tennessee Eastman process, because obviously we can't share the modeling work that we do for our clients, but we have produced a Tennessee Eastman process that we can share with everybody. And we can implement it as AML or SysML and references it to PCA libraries. And this is just a picture of the Tennessee Eastman process. I've included, for whoever is interested, a paper describing what we have done. And we have a website that you can visit. And we are willing to share with you our enterprise architect SysML model. And there's an export file that you can use to import the model into other tools that you might use. And also different version of XML that you can also use to import in other tools. At the moment, the DEXPI process standard is very close to being published on dexpi.org. The hearing period has been closed, so I don't know the date when it will be available, but I expect very soon. And then I want to go back to why do we want to do this? I started with our vision. And I now have talked about the modeling and the standard that we are trying to do for the flow diagrams and the block diagrams, and that we want to start to use intelligent P&IDs. And our motivation for doing this is that we see that it enables us to create a rule engine or artificial intelligence, if you want, that would see that we have a need to do something. And on this project, we have the philosophy that we will do this way. And that way we can automate the production of the P&ID. And also we can, since we also digitalize the P&IDs using the DEXPI standards, there is a possibility to use a rule engine to create components or assemblies for the 3D modeling. So that was what I intended to say. So are there any questions?
Thank you, Monica. Do we have any questions? I think I have someone from Henrik. Welcome.
Yes, correct. Thank you. Hey, Monica. So I missed a little bit in the middle of the presentation, but I'm trying to figure out. So I used to work a lot with standardization called PADIM, Process Automation Device Information Model, which is basically creates a standard taxonomy for any kind of asset and how it should be modeled towards supervisory control, more or less. Is that something your DEXPI is adapting to, or is in competition with, or how does those standards fit each other?
I don't really know that one, so I couldn't really give you a good answer to that. But obviously, this is an information model that allows you to store the information of why you did, what choices you did, what choices you took away. And you can keep it alive throughout the life cycle of your asset. So as we intend to make it a standard, we see that this will be possible for other standards to use information from that one. That's the general answer I can give you.
Does DEXPI standardize the taxonomy of the different interfaces?
Yes, they do actually.
Okay.
So, yeah.
Thank you.
So that there is the porting that we have in DEXPI process, and in DEXPI, the DEXPI standard, which is for the P&IDs, there are types of function blocks and types of attributes defined for each of them, so it's standardized.
Okay, cool. Thank you.
Yeah.
Thank you. We have another question from Henrik. Welcome.
Hi again, Monica. Thanks for presentation. I think if I got you right, I think you addressed the question there is to Peter before about structures and that sort of information. If that is correct, that you by this can handle structural information in a standardized way, then I would like to ask you if you have encountered any problems combining the DEXPI standard, your solution with the CFIHOS standard. I would prefer to have one common package for all this. Do you have any comments on that?
Yeah, we have been. That's why I made the comments. I was so happy that they were moving in the direction that we want them to go to, because, as I say, we have structured data. So we, the information model, you can, I would say, not inherit, but based on the choices you made on the top, you have suggested things that you should use. Okay, so you have an operating window, so to speak, of a base property, let's say pressure or temperature, and then when you are specifying the equipment, you start to say a lot of things about it, like it's the maximum operating, or it's the minimum operating, or it's max allowable, or the max design, etc. So we typically in the specification of the equipment that we're going to buy, we maybe have 10 different pressures that we talk to, and then you add on the physical of where in the equipment. So then you get the hot side, the cold side, the suction, and so then you kind of suddenly have 20 pressures. And in today's CFIHOS model, the way they have structured their properties, they have created all of those 20s for each of the equipment.
Right.
And in the future, I'm really happy to hear that they want to go along with our idea of that every object has a base properties, and then you say what kind of information are you giving about the properties.
You're right. If I got it right, so you can handle all this in the same package, so to speak, or as I see it right now, you have to use different standards or different RDL if you wish to accomplish both the requirements and then the structural information.
That is true, and one of the challenges that exists that this thing about the aspects, it's not the same structure in each aspect. It's individual structures in the aspects.
It is
and CFIHOS is so firmly in the product aspect. So this hierarchy and structure of that one it's not the same as the functional information model of the same asset.
Yeah, gotcha.
That is a challenge, but I see that that can be solved by that you have groups of activities or functions that you link to a group of function of products or components.
Yeah.
So it's not going to be a one function per component. No, it will be a group of function per component, or a group of function for a group of components. If you see, so it's going to be many-to-many relationships.
Yeah, right. Okay.
Thanks. I don't know if that answered your question.
Yeah,
but
yeah, I think so. Anyway, enough, because I see the challenge, and I think you've done a great job, and keep going on. Okay.
Yeah, thank you.
Thank you.
Thank you, and I'm glad to see that Heiner has reached his hand. So maybe he can help us even more, because Heiner is representing DEXPI.
Yes, okay, thanks a lot, and for the excellent presentation, Monica. One answer to Eric, we have not different resource definition libraries. We always try to use ISO 5926 part 4 edition 3, and we reference from DEXPI Plus, from DEXPI, and from CFIHOS always to the ADL 5926 part 4 edition 3. And therefore, let's say we are all in the same boat, and they are not different.
All right. Okay. Thanks for that as well.
Was it a little bit more clear to you now, Henrik? Or?
Yeah, I think so. And I mean, just realize that we struggled with the same issues, and that's why we're here. And
yes, definitely.
Heiner.
We have a second question from Heiner. Or no?
No, I tried. I had only the comment to Eric.
Yeah. We had another question from somebody. I cannot see from who, but there was a second question up. So whoever pulled that, please welcome. No. Any other questions to Monica? No. In that case, I will thank you very much, Monica, for this nice presentation. And then I will leave the stage now, not only digital, but even physical, to our own Erik. So welcome up, Erik.
Okay, I will try to summarize and talk a little bit what we are doing in Sweden now about the projects we are running and have run during the years from 2019 when SEIIA was founded. But I think I should start with this picture, why we are why we are here and why we are doing this. And as you see, we have a vision and we have a mission, and I will not take more time on that. But if you want to go deeper into what we are working with and what we are doing, you could look at our website. As you have seen today, we have several corporations all around the world. Today we have met CFIHOS, we have met DEXPI, we have met ILAP, and we have other communities that we work with around the world. So we are in a good hands with friends around the world. So it's when we talk about acting global, this map shows a bit of what we are doing. And I would like to give a thanks to PIA, the organization in Sweden that's founded lots of our projects during the years. So I have a list of projects on the right side where you can see what we have done during these years. The LCD phase 2, the NIC Sweden, and the AutoPID, AutoTwin, and now we are working with Digitala Stambanan and also with the IDO project that have been mentioned several times and closely connected to what Robert started to talk about this after the start. And we're also working with the Arrowhead project. I will come back to them a little bit more. But I will also recommend the Swedish audience, at least, to look at this 3. You can find them in digital way also, but the PIA has done this to made these papers and the white papers and it's much of the thing in this come from the project that we have been working with together with PIA. So it's really good to see that the work that we have done together in these projects have been also been spread out in different type of channels. So if you want to take a deeper look in this, you can just go into send an email to us or go into the PIA website and make a contact there. Okay, I will try to continue. Okay. I will start with this. This is an old project. It's not ongoing right now, but the life cycle data management phase 2. We was working with different type of Excel sheets that were used in the industry, and we tried to make them connected to CFIHOS. So in this case, we run a project. So we start a project, a pilot project that we try to use this type of Excel sheets that were used today in the industry, and we just put in the CFIHOS identification in the columns. So this is an example from the SEIIA that we have tried to make a CFIHOS compliant SEIIA Excel sheets. That is not. This is not high tech, but it's some proof that you could use this, for example, the CFIHOS standard in an ordinary specification that we are using today. So that to this first step to a more digital information exchanges could be done very easy in this way. And the next step, we try to get more information into this specification, and we did during the NIC Sweden project, we made in this case a pump specification where we have all the attributes that you could find in the CFIHOS standard as a template. And the interesting, when we send one of these templates to one of the big EPCs in Swedish pulp and paper industry, we got this answer that today they are making much of this information exchange manual. They take the Excel sheet and they try set up some people to fill the Excel sheets with they think correct data, and then they send it back to the customer. But with this type of standardized Excel sheets, they could more or less automate the exchange. And that's, I think it's one step further that we could really achieve both cost and better quality in our information exchange. And I also will talk a little bit about DEXPI. Monica talk about the next generation of DEXPI, the DEXPI Plus or DEXPI process. But this is when we try to use DEXPI in a real project in Stora Enso. That was during the life cycle data management phase 2 project also, that we tried to use the DEXPI concept to really exchange information between different type of actors in a project. And the interesting here that you have as many realize have seen before, classic P&ID schema, and the right is the same. But that is in Excel format, and this is not so easy for us human to read. But as you can see, they are references here for the 5926 standard. So that the content of the XML file is based on 5926 reference data, as we started this day about reference data. So all this XML file is based on international standardized reference data. So that's also about something that we have done. Now I'm jumping to a new project, a project that we are ongoing. We are a part of a national national project that calls Digitalisation, and I will not go into deep to what we're doing, but in this picture you could see the representative companies that are joining this project. We have academic organization, and here you find us. We have PIA, naturally we have Luleå Technical University, for example, and we also have suppliers, and we have different type of owner operators in this project. So it's very good combination, and also different type of industry domains. That also very interesting view of this project that we could meet, for example, from our view, Volvo, Ericsson, and steel companies, energy companies, and chemical companies, pulp and paper companies. So it's a nice mix of industry in this project. But what are we doing? What we are doing in this case, in the case that SEIIA is involved, is one of the industry case 5. And in that one, we have today 3 different type of sub-projects, I could say. We have done it once with one of them are done with the Luleå Technical University. That's the model you see in the bottom. We have a small model of a process, but this picture on the side is showing the ontology of this process. And we are not going in now to the details, but this is one of the projects we are running now, how you model it based on industrial ontology, data ontology standard. That's we are also involved in the development of. The next, we have two other cases. One is connected to the Neuron chemical company, all over the world. We are starting up now a pilot with them to use the IDO for making a model of their production, and use IDO for reasoning. The reasoning is that you could make intelligent decisions for the data you could put into the model. And the last one is that we are working with Siemens Energy about their asset model, and we also in that case using the IDO for their ontology there. So this is 3 very interesting use cases that we are working with in the IDO in the IC5 project. Something else that we are working with there also is the digital product passport. Maybe some of you have heard about this before. We are focusing on the consumer part of the digital product passport, I would say. There are several other views and that you could go into this, but we have focused on the consumer part, because if you go into the owner-operator side of a plant, what will be the demands in the future around the digital product passport for a asset owner? So we are looking into this a little bit deeper, and we also had found that there are ongoing initiatives around the world connected to standardization, naturally. This is just in the beginning, I would say, from our view, but it's a very interesting to see what they have done in the IEC community, and this is a standard about how you could mark your components that you put into your asset, and that is also connected to the asset administration shell, and that in that also connected to the product digital product passport. And the most interesting is that this is proposed for the European Commission as a basis for the future digital product passport for components in the process industry. And we will continue this work because this is an ongoing project. We have a workshop for the 23rd of November that we go deeper into this. And we hope that we'll have representatives that work with this around this and get more knowledge about what they have done already. As mentioned in the beginning, we don't reinvent any wheel, so we start from something that we could maybe get better. Okay, that was Digitala stambanan. A part of the Digitala stambanan is another project that have been mentioned several times, the new standard for industrial ontologies, IDO, and we are a part of this. This picture I have borrowed from PostCaesar in Norway, but as you see, IDO is the grammar of digital language that enables transition from documents to information model as carriers of information in work process. And this picture is coming from Equinor. As you can see, also connected to what Monica just said about the different steps in a process. You could see the ontology for the model of your asset are increasing during from the basic IDs to a asset in operation. And this, as I also could connect to what Monica said, this is also connected to the 81346 assets. I don't find. We skip that. You could see the pictures there, the color on them. We continue. But also one interesting thing maybe for the audience here, that we also realize that this is a new step, at least for the Swedish industry, to realize what is this and what will it mean for the Swedish industry in the future? What type of competence do you need in the future? What type of systems will we have in the future? So we are working with setting up a basic course about this inside this project, and so the idea is to invite the members of our community, SEIIA, and also the project partners in IC Industry Case 5 in the Digitala stambanan. So that's something we are working with right now to set up this course. And what is the ISO 23726? It's a very new numbers. It's difficult to explain them, but yeah, it's a ontology for representing this industrial data and information, and it's based on 5926. We have come to that several times today. It's based on V3C, OLV, Ontology Web Language 2. And also there, it's based on a standard. It's not something that is reinvent from somewhere. And today we are having 54 classes and 92 semantic properties. And it's also already used in Norway, for example, in oil and gas industry. So it's one of the goals for the Norwegian industry is to get this as an international standard that they have done from, I think, 2014, not will spread away and instead of reusing it and getting to a standard. And all the reference data about this you can find on the PostCaesar website. If somebody likes to have links about what you are talking about, just give me a mail afterwards. I can try to, and I will support you with links, whatever it is. Yeah, and the goals are the first part of this is to develop the industrial data ontology that is called IDO then. But also what Robert talked about in the first session, the ontology for scheduling. So what Robert Skaar talked about will be the part 4 of this standard. Right now we are working with part 3, but part 2 will starting in the beginning of next year. And also the IMF that Monica mentioned in her presentation is mentioned to the idea is to put that into this standard also. So we'll several parts of this interesting use cases and standardization efforts will go into this ontology standard. This is an example, not so easy to see on the screen maybe, but this is on the website, the reference data services that POSC-SEIIA provides. You could find in this case a junction box example, and I could show a little bit bigger. So in this case, you have model the junction box properties and classes. And if you as an old electrician, you could see that if you have the cable of a specific standard of cable. In this case, one of the main cable is a 16 pair cable, and then you have a 2 pair double pair cable, and if you go break down that more, you could in this case see the conductors and terminals, and as you see, this is the ontology connections has a part connected to and so on. So this is the basic in the ontology that you could use for structuring a asset. Now this is only a junction box, but if you have a complete asset, you realize it is very complex. It will be a really complex model. But it's interesting to see that we have come so far now, and also that we from Sweden work together with the international network around this work. So this work is actually, as it is as ISO standard, it's have been approved from ISO, I think 2 weeks ago, that this standard are going to be built, and also there is a standard working group starting up with this. And myself and also Torbjörn Holm from Eurostep is participating in this working group from Sweden. So we are heavily involved in this work, and we are also providing these 3 use cases you have seen in the further pictures. The pump model, the process from Neuron, and the asset model from Siemens Neuron. That's from Siemens Energy. That is mentioned to be the use cases inside the standard also, if everything goes as we think. So that was the IDO and Digital Stambanan project, and then we go over to this last project that we are involved in. We have the network we have in our Nordic countries, Norway and Finland and Sweden. We have worked together from 2019 around how could we do something together in a bigger way. That's also something that Robert Skaar said to us when we met the first time. And we have been working with this together, and we are very glad that in the end it get into this. This is a European very big project. So I think our efforts are to start something ended up in this. And today we are part of a European project. There are 43 partners in this, 12 countries involved, representatives from different domains, automotive, aerospace, and process industry. Unfortunately, green energy is not with us anymore, so there are only 3 domains, industry domains left. But the project is based on 3 pillars. One is the Microsoft paradigm, and that had been done in the Arrowhead project before. So it is a framework that we could use with inside the Arrowhead that we could reuse there. And also one thing is that we are looking at different type of data models that we are focusing that how they are working today and how could they maybe join each other in the future, how could they align with each other. That's also work that we're working with. So we don't don't reinvent any more wheels. So we in this major industrial data models, we're working with finding connections between the different type of data models in different domains, for example, automotive and aerospace. And the last one is that we are trying to translate when we find that the data models are not fit together, then we could use AI for transformation of different type of informations that they are fit together with that type of new technology. I'm not the right person to describe it in detail, but they are very interesting things that are ongoing in this project. And it's also very high level, I would say. This is a picture of the Microsoft attribute that we are using in this project. As Eclipse Arrowhead is the name of that one. The major data models I've mentioned is one of the work packages, and also now when we are running this IDO project, that's have come into this one. So one of the add-on things that we have seen since we starting this project is the IDO ID, and that will be a very big part of the Arrowhead project also. So it's a very close connections to the development of the new standard for ontologies and connected to this project Arrowhead. So that will be very interesting to follow. But this is a 3-year project, so it's until 2026 we are working with this. And also the automated model translation in the work package 4, that we are using this industry, this type of systems for making translations between different type of standards and also data formats using this. And the whole project is divided into different type of work package, and as just put in the members of SEIIA inside this. So we are part of the work package 11, dissemination and standardization, and we also following very closely the translation and major model language and the Microsoft service paradigm that we work with and follow very closely. But we also have Eurostep that are responsible for the translation work package. And we have Johnny Sundström that you started this day with. He's responsible for Stora Enso, part of the process industry work package. So in this case, the problems that the work package find in their daily business, that this 3 work package will solve with different type of methods. That's you could say the base idea of this project. So it's very interesting to see what, for example, AI could do with translation of information between different type of domain aspects, for example. So that was a fast flyover what we are doing in our community. So
yeah, thank you, Erik, for that. Do we have any questions for Erik or his presentation, my friends? Are you still awake? Anyone? Thank you. Then I say thank you once again to Erik. We have something here from Hans. From Hans. Welcome.
Sorry, I was just going to react. I pressed the wrong button. Sorry for that.
We are also quite eager to know and get feedback on this day or afternoon. So please contact us if you have any questions or if you have something that we can improve or something that was good that we can do more of. So don't hesitate to give us all the feedback we can get. And if there's nothing more, just thank you for listening.
Thank you. Have a nice evening.
Yeah, and have a nice evening. Bye.
Bye.
See you next year.